Hi, I'm Steve Ward and I'm a pre-sales consultant for Emerson. In this session, I'm going to take you through our Logic Developer PLC component of PAC Machine Edition 10. So PAC Machine Edition, this is our programming and configuration software for our PAC Systems product range. A Logic Developer PLC is the component of PAC Machine Edition that's used for developing PLC-based applications. We also have View, which is a HMI SCADA, including configuration for Quick Panel Plus and PAC Systems operator interfaces. And there's also Logic Developer PC, which is the programming engine that can either be used to turn your computer into a soft PLC and also runs inside the Quick Panel Plus and the PAC Systems operator interface. We have some other PAC software as well, and I'll talk about that as we go through these slides. But the focus will be on PAC Machine Edition 10, how it works and how to use it. For more detailed instructions on how to use PAC Machine Edition 10, we do have very good getting started guides, and we also have training courses that take you through the individual steps. My view is that PAC Machine Edition 10 is relatively straightforward and intuitive to use. If there's anyone who's already used one of our competitors' programming software packages, they should find that PAC Machine Edition is very straightforward to get used to within just a few minutes or at most a few hours of familiarization. We start with a safety moment. Emerson is very concerned with safety, both for our employees, our customers, our users, and from a corporate point of view. So for safety, our recommendation is stay safe, and you can start by reviewing your working environment for any potential issues before you start any work. Look for trip and slip hazards, make sure you adopt safe lifting processes, look for electrical issues, be concerned about desk and computer ergonomics. If you're driving, drive safely. When you are on site, wear appropriate protective equipment. Make sure you're working safely at height and adopt ladder safety. And for fires, follow alarms and exit routes. If you're not sure if it's safe, then you're empowered to stop work and seek support and make sure it is safe. And also, if you do spot unsafe conditions, you're empowered to help and fix those yourself if appropriate. Any issues should be reported, including near misses, so that we can make sure that we track safety issues and prevent unsafe conditions from arising in future. And take a look at these 12 life-saving behaviours. These are the safety actions that Emerson recommends you undertake. So Emerson's PLC business has a wide range of components for PAC Systems, which is the PLC range, Movicon is our HMI SCADA, Package is our Industrial Internet of Things, and all of these, along with related items such as industrial PCs, network switches, power supplies, these make up our overall portfolio. In this slide deck, I'm going to focus on programming and configuration for the PAC Systems PLC range using the PAC Machine Edition software and our PLC Logic Developer development package. Before we start, let's take a look at the overview of all of the PAC software we offer. So PAC Machine Edition, this is our overriding development and configuration package. It's intended to be a single tool to include programming, configuration and maintenance of entire PAC Systems automation portfolio, not just the PLCs, but also the operator interfaces, things like motion control, safety and so on. And PAC Machine Edition includes the tools and the options required to help us configure those devices, program those devices, and fault find and determine issues with those devices. It covers hardware configuration, so you can configure the controller, the I/O, including Profinet I/O. It includes operator interface and HMI configuration, VFD configuration, servo drive setup and programming, Ethernet switch configuration, safety applications, including redundancy and the sensor control. For the actual control logic programming, we support IEC 61131 Part 3, and we're also a member of PLC Open, which further works on supporting interoperability between different PLCs programming packages. From the IEC 61131.3 point of view, we support relay ladder, structured text and function block diagrams. We also support native C blocks. The idea here is you can compile a C block using an open source C compiler that we provide, and then you can run those C blocks inside the controller and they can communicate with the PLC's data table, or you can control them using parameter access. That's going to be outside the scope of this slide deck, but I may cover that in another slide deck later. As well as having the standard relay ladder and structured text and function block type function calls, we also have over 180 advanced and process function blocks which allow you to implement demanding applications, including safety under IEC 61508. Now, PAC Machine Edition does support object-oriented reusability. We support user-defined function blocks and user-defined data types. The idea is to build applications rapidly using pre-configured objects from the Toolchest, and also allow for reuse of components that have been used before in previous applications. PAC Machine Edition also supports diagnostics. You can display the controller status, you can display data from the PLC, you can display online evolution of the logic, and you've got fault table integration. As well as programming the PLC, we also support the operator interface development, allowing you to build HMI panels and controls logic in this single integrated development environment. And we also have simulation, allowing you to test the application even if you haven't got any hardware. You can download to a simulated device and use that device just as if it was a real device with all the capabilities of PAC Machine Edition, except you don't actually have to have that physical device present. Increasingly, cybersecurity is an issue for automation applications, and one of the key aspects is using OPCUA, and OPCUA is a modern high security protocol, but in order to have security we rely on the use of certificates. So certificates allow you to sign messages so that you can know who the message is from and know that it is a trusted sender, and also those certificates allow for encryption as well. So you can actually encrypt the message so no one else can read them, and that also means that they can't be tampered with, so that eliminates any possibility of man-in-the-middle type attacks and any external hacking type attacks. Now, security is great, and we're building OPCUA on the back of public key infrastructure, which is a well-known security mechanism. But there is an issue with certificates, is that they are designed for use by IT practitioners, and not every OT practitioner is able to understand and use them. So IT, of course, is information technology. These are the people that work in the data centers and manage the centralized systems, where OT is operational technology like HMI SCADA and building PLC applications, and those developers may not have all of the skills that are required to implement the certificate management. So the idea of PAC Security Center is to easily deploy and manage OPCUA security and improving efficiency on configuring the entire system. Efficiency improvements can exceed 50%, and that supports things like rapid recovery from node failures using a single click, and that results in reduced downtime, and there's also a troubleshooting tool to facilitate finding security configuration problems. For example, with OPCUA certificates, you need to have the right certificate in the right place. You need to have the certificates distributed around all the nodes that will communicate with each other, and the certificates themselves must be valid. And for cybersecurity purposes, certificates have an expiry date, so you must make sure that that certificate is before it's expired. Otherwise, if it has expired, then the devices may reject the certificate. It's also possible to withdraw certificates. So a certificate may be valid, but you can withdraw that certificate in case, say, somebody leaves or a device on the network has been compromised and you no longer want it to be able to communicate. So that certificate could be blocked to the higher level. So there's a lot of aspects of security which are quite hard to manage, but PAC Security is intended to be able to cover those. So the PAC Security Console provides an intuitive administrator console allowing you to connect to the PAC Security server. The server is the process that actually stores the certificates. It allows you to register OPCUA security certificates so that they can be used by multiple devices. and it allows you to manage those certificates, including creating them, checking their validity, and withdrawing them as well. And the PAC Security Server also supports security certificate management with registration services to make sure that all of your high security devices can talk to each other. Another issue for project management is managing all the different versions and configurations of all the different applications that may be installed on a site, or if you're a system integrator or OEM, it's all those configurations that may have been shipped to end users. Now, in the IT world, there are various version control systems, and what Emerson has is PAC change management. So PAC change management is an integrated part of PAC Machine Edition, and it can also work with other software such as HMI SCADA and also documentation such as Word, Excel, and so on. What PAC change management does is it allows changes to software projects to be tracked over their life cycle, and it implements that version control software in a way that is again designed for these OT type users rather than IT type users. So the PAC change management server, this provides a central repository for project documents and configurations. And the way it works is when a user comes along, they would log on to the PAC change management server, they would check out a project onto their local computer, but a copy is always preserved on the PAC change management server. The user then performs the work on their client computer, and then when they've finished work, they can check that project back into the PAC change management server. So the benefit of this is it means that all the versions are maintained on the PAC change management server, and you also get secure access to all of those applications. So PAC change management, it provides that secure access, it provides audit trails, and you have role-based access. So there may be different levels of users who get access to different parts of the applications, and an administrator is available who can check out projects and see what they do and see who lost access to project. And it also supports a version history because you can see what changed for each version. Every time a new project is checked into the server, all the old versions are preserved, so that gives you a great history over the evolution of a project to find out exactly what changed. Just in case somebody doesn't return a project back into the server, an administrator can override the checkout. That would of course result in an uncontrolled copy, but that at least allows you that if a computer is damaged or someone goes to site and doesn't follow up the processes when they return, you can at least make sure you have the last but one update in the change management server so you don't lose all of your work. If you've got multi-user teams, then it does allow collaboration on projects, and it also supports eliminating of users inadvertently overwriting change made by others. One of the ideas there is that multiple users can check out a project, but only one of those users will have write access. The others will be able to use the project to read what's going on, but they won't be able to make changes and overwrite what other users might be doing. PAC change management also includes a scheduler, so you can automate repetitive tasks such as backups. So the change management server can regularly connect to the actual physical devices, the PLCs or the HMI SCADA servers, and it can perform a backup of those operations. So even if people are coming along outside of the change management environment and they're making changes locally using their own backup copy, or maybe by uploading from the PLC and not using change management at all, then you can make sure that by having a regular backup, you still maintain the latest version inside the PAC change management server. For validated environments, we also support e-signatures, so you can have change approval management, and that can also be part of your operations. And as I mentioned, it's directly integrated into into PAC Machine Edition. So when you load up PAC Machine Edition, you have your local projects, but you also have the possibility to connect to the PAC change management server and check out those projects, and then also check those projects back in when you're finished with them. So PAC change management, this is an OT responsible version control system that is very good for the users of PAC Machine Edition, but also of other applications which are involved in automation projects. So let's move on to the PAC Machine Edition environment. I'm going to be focusing on Logic Developer PLC. There are other aspects to PAC Machine Edition, such as View and Logic Developer PC. There's also the change management and PAC security that we've just seen, but I'm going to be covering this for the majority of users who are developing applications for PAC systems PLCs. We'll start with some definitions. So PAC Machine Edition is the overall environment. Logic Developer PLC is the application for programming PAC systems and other legacy PLCs. So I mentioned PAC systems, but it also includes Versamax PLCs, Series 90 PLCs, and other legacy PLCs. Within the PAC Machine Edition environment, there are also other utilities for motion configuration, I/O configuration, diagnostics, and so on. For example, for use with Profinet, we include a DCP tool that does the discovery and configuration protocol management to allow you to discover Profinet devices and configure those devices. Similarly, for Profinet, we also support GSDML file management, so you can manage the GSDML files and import them and also use those to define the I/O configuration for your Profinet I/O devices. We also do the same for DeviceNet and for IO-Link to some extent, but also for Profibus and for other applications which have that sort of I/O configuration mechanism. Now, I mentioned PAC Machine Edition View. This is the application that's used to create operator interface applications, and that's firmly embedded inside your projects. But as I say, I'm not going to be covering this. So we start off with a high-level project, and what a project is generally the user application which pertains to an individual machine or cell. So in many cases, a project contains a single target, where a target is a PLC or maybe an I/O drop or maybe an operator interface. But the idea of having a project is you can combine multiple targets into the same project. So maybe your system comprises of one or more PLCs, maybe there are several remote I/O drops, maybe there's an operator interface. You can combine all those targets into a single project, so everything is managed in one location. Now, inside PAC Machine Edition, you have various windows. There's the info viewer, which is the main screen area, which is also used to display help information. There's a companion, which is really useful when you get started with PAC Machine Edition, because this is an online context-sensitive help window, and you can click on other items, and the companion will give you immediate help based on what you've selected. There's also an inspector. The inspector gives you detailed configuration for an item you've selected, such as maybe the configuration of a variable or an I/O point. Maybe it's the detailed configuration of a Profinet device, or it might be the configuration of some other aspect. I mentioned variables. Variables are the words we give to represent an internal or an I/O memory item. So that's maybe an I/O tag, it might be an internal memory, might be a system variable. So there are multiple variables in a typical application. And again, PAC Machine Edition can manage those variables, and we also support drag and drop between different applications. So if you've got multiple PLC targets or operator interface targets, we can support drag and drop between those to simplify integration of those multiple targets. Now, variables can be symbolic, in which case they stand alone, but we've also got mapped memory, such as %I for inputs, %O for outputs, %R for registers, and so on. And in these cases, these are data tables consisting of multiple instances of that mapped memory. So that's where the data tables come in, and we can map variables to the data table or have them individually as symbolic addresses. And I mentioned the Toolchest. The Toolchest is a repository for common functions, so you can store them in a central location. It can be used for code snippets, it's used for GSDML files, and it has multiple functions within the application to allow transferring of files and data and other aspects between targets and between projects. So what do you need to run PAC Machine Edition? Our computer specifications are listed here. I recommend a minimum dual-core 2 GHz CPU with 8 GB of RAM. Hard disk space, you could get away with quite a small hard disk, but the bigger the better, depending on how many applications you've got. And then our recommended application support here would be a quad-core computer or more with a 3+ GHz CPU. So this would be a relatively modern CPU, 16 or more gigabytes of RAM, and a 512 GB SSD. Generally, the more RAM you've got, that supports larger projects. It also supports multiple instances of PAC Machine Edition running at the same time. And of course, a larger disk, particularly if you use an SSD, SSDs are significantly faster than legacy rotating disks, but also a larger disk allows you to have more projects. It also supports wear leveling, so larger disks tend to last longer. But the key reason for having a large disk, of course, is just to have more data. Now for the screen size, I recommend high definition, which is 1920 by 1080. PAC Machine Edition will run on larger screens. I have successfully used PAC Machine Edition on 4K screens before, but PAC Machine Edition isn't very good where you're using font or text scaling. So if the text scaling is at 100%, it works fine. But if you've got eyes like mine, then if you're using a large screen at 4K, then at 100% text scaling, the text can be very small and difficult to read. So if you go down to HD, then you get the ability to still have a lot of information on the screen, but you can also read it. Again, your mileage may vary depending on how good your eyes are. And again, the larger the physical screen, then the easier it gets. I did at one point have a 43-inch 4K monitor on my desk, and that was fantastic for PAC Machine Edition use. You could run everything at 100%, but the problem was that monitor was enormous. You kept losing the mouse, you couldn't find windows, so now I use a smaller 32-inch screen, but because of the scaling size at 125%, PAC Machine Edition sometimes does struggle a bit with that. It still works, but it just sometimes it gets a bit awkward in that some of the fonts don't scale as you would expect them to. If you use high definition with 100%, then again that works fine. And high definition, that's a typical monitor resolution for a laptop. So PAC Machine Edition does work quite well with standard laptop type displays. In terms of the operating system, we can use Windows 10. We support Windows 10 22H2 and above. We also support Windows 10 IoT Enterprise 21H2 and above. Now, some people are saying that Windows 10 is now obsolete. Well, Microsoft did withdraw mainstream support for Windows 10 in October 2025, but it is still possible to get security updates for Windows 10, so you can carry on using it. And if you're using the Windows 10 IoT Enterprise versions, they generally come with long-term support anyway until 2029 or even 2032, depending which version you've got. So Windows 10 is still a very popular operating system, and we still do support that. Many users will now be switching to Windows 11, so we do support Windows 11 21H2 and above. You can also run PAC Machine Edition on Windows Server. We've just withdrawn support for Windows Server 2012, which is fair enough, it's 2025 right now, so that's a long time ago. But we are still supporting Windows Server 2016, 2019, 2022 and 2025 versions. All of these need to be 64-bit only. We don't support any of the older 32-bit operating systems. Certainly we no longer support Windows 7 and Windows 8. They are long gone. And then on the system settings side, we do recommend that you use US English. I have successfully used UK English before, but US English is recommended. Again, it's partly to do with font support and character sizing and a few other aspects such as date and time formats. So US English is recommended, but some other formats may work. A few extra notes. Installing PAC Machine Edition. The way that works now is our software distribution is cloud-based. So when you buy PAC Machine Edition, you will get an email giving you an authorization code and also a link to the download site. What you can do is download PAC Machine Edition. Typically it's downloaded as an ISO. So you've got a choice of either mounting the ISO and running it as if it was a virtual CD drive, and then you just run the setup utility. Another option is you could use something like WinZip or 7-Zip, and you could then unpack the installation files from the ISO into a local folder, and then you could run the setup from there. So quite straightforward to install. Once you've installed it, then it will work for 4 days without any authorization. But after that, you'll get error messages and it will stop working because it will tell you that you haven't got a license. It still lets you run PAC Machine Edition, and you can still open applications, but you can't go online or save anything. So from a practical point of view, it's next to useless. So in order to use PAC Machine Edition beyond the 4 days, what you need to do is you need to run the license manager, and then you need to authorize the software using the authorization code that you will have received. It's also possible, as well as having a authorization code which is locked to your computer, you can also use a license server. So there's a way there of setting up a separate computer in order to run that license server, and then you can use the license manager to lease licenses from that license server. And that's a very good way of managing PAC Machine Edition licenses in large organizations. You would have a central administrator, a central license server, and then the users would be able to lease the license from that server. We also support USB keys, but I would say these days USB keys are going away. First of all, there's a risk that you might lose them. There is a risk that they might be damaged or even stolen. And I've also seen in some cases USB devices are blocked by organizations. So of course, if the USB is blocked, then we can't recognize the key and it won't work. USB also needs some additional services running inside the computer, which are part of the license system, and that can also cause issues in some organizations where that's blocked. So for most people, you would use a computer lock license with a local individually authorized license, but again, that license server is also a possibility for larger organizations. So once installed, you can run PAC Machine Edition, and you will get this framework that gives you an overview of what's installed on your computer and what aspects are available. One thing to note is that all of these windows are resizable and reusable and removable. You can also pin them to the side to move them out of the way. You can close them and reopen them. So your view may look slightly different, but this is the view I prefer to use. And to break this down, this is what you will see as part of your application. At the top, you have a title, menu bar and toolbars. They are Emerson compliant, but they also conform to the Microsoft Fluent UI interface standard. So as you move through, you get a combination of different menus and titles. You also see nice icons which explain what you can do. And as well as these titles and toolbars and menu bar, you can also right click in many places, and there are right click menus which duplicate or repeat some of these functions. And many of these functions also have keyboard shortcuts. Not all of them, but in many cases it's possible to use PAC Machine Edition without taking your hands off the keyboard, and that can reduce RSI and other injuries, and also it makes it more suitable for use with faster typists compared to continually moving your hand to the mouse and back again. So the title, menu and toolbars, they remain at the top. Some of those toolbars, by the way, are context sensitive, so depending whereabouts you are in the application, certain functions may or may not be available and they'll be grayed out. And sometimes toolbars are only available if you're actually within the right section. So for example, there will be an online section which is only appropriate if you're actually online. And there may be other toolbars which appear or disappear according to the context of what state you're in. Now moving around the screen, the next thing you have is in the middle of the screen. This is the info viewer I mentioned. So when you first start PAC Machine Edition, this displays all your getting started and help information. So there's information there about Logic Developer PLC, and you can expand that and you can click on Getting Started and Support, and these are hypertext links to enable you to find out more information. What also appears in the info viewer is as you open applications such as I/O module configuration, or if you open logic blocks, they will also appear as additional tabs inside that info viewer area. Now, although they're tabs, you can also move those tabs around. So if you've got a piece of logic that you want to fill the screen, you can do that by moving it around and minimizing and maximizing. You can also close them down. And if you lose anything, then you can always bring it back by going to the view menu, and then you can choose what particular aspects of the framework that you see. So if you do lose something, you can bring it back. Now, this is my preferred arrangement here. So I like to have the info viewer in the middle. I like to have the navigator over on the left and the inspector on the right. So the navigator is the aspect of PAC Machine Edition that allows you to navigate through your applications. So the key tab there is the Manager tab, which allows you to manage all of your projects. You see there is My Computer, which is local projects. You always get samples, which are installed automatically, although you could actually deselect that during the installation wizard if you wanted to. There's your local projects, and you see I've got one called CPL 410 Demo. You can also have shared projects. That's disabled in this case, but shared projects allows you to navigate to a shared network drive. So if you've got multiple people in an organization that are sharing projects, you could share those on a shared network drive, and then they would be accessible to every user. And if you're using PAC Change Management, you can also select PAC Change Management projects from here as well. There will be an extra node for the Change Management server. Now within the Navigator, I'm selecting the Manager tab here, but we've also got a Project tab. And when you open the project tab lists all the aspects of your project and your targets. There's also a tab to display help information. There's also an Options tab. The Options tab allows you to set up how the system works and how it's viewed. So for example, when you display ladder logic, you can choose whether you have a brief view for variables, a full view, or no variables at all. So you've got lots of control and flexibility over what the interface looks like, including things like colors and so on. And there's also a Variable tab. The Variable tab lists all of your variables within all of your targets when you've got an open project. Now the inspector is over on the right hand side. By default, the inspector normally appears underneath the Navigator, but I like to move it over to the right hand side by grabbing hold of the title bar and just dragging it across. And then you will see locator icons which show you where it will be dropped into. So you can have it appear completely on the right or on the right of the info viewer, but still have a lower section and so on. I'm not going to show you this, but that's easy to navigate, and you'll be able to see that when you use PAC Machine Edition yourself. So the idea of the inspector is the inspector gives you more detail about the item you've selected inside the Navigator. So in this instance, I've selected the CPL 410 demo, and the inspector tells me a bit more about that demo. It tells me what is the name, what is the product, PAC Machine Edition, what is the version. It's set at 10.6. When was it last saved? It was last saved using 10.7. You can see when it was last modified. You can see who the user was. And then it tells you the description, if there is one entered. And then you can see how many targets there are. And I haven't expanded it there, but there is the CPL 410 target. And by clicking on the plus button, you can expand that target to see more details about that individual target. Towards the bottom of the screen, starting on the left, we have the companion. The companion is context-sensitive help, and the idea is whenever you select anything, the companion gives you the help entry for that item. So in this case, I've selected a local project, so the companion is telling me what a local Machine Edition project is and what I can do with it. And you'll notice there's that question mark there in that blue sort of circle. If you click on that, that will open up the detailed help for local Machine Edition projects, and that will appear inside the info viewer area. So the companion is really useful when you're starting to learn PAC Machine Edition. I normally leave it on display anyway, but it does use up screen real estate, so you can turn it off, or you can minimize it, or you can resize it if you don't need to use it, or you don't need to use it as much. Now in the middle, we've got the feedback zone. You'll notice that a lot of these options, they have multiple tabs, and the reason we do this is to try and fit as much information on the screen as possible, but without having so much information that you can't see anything. You know, it's like you're trying to see the wood for the trees, if you like. So we have these multiple tabbed views, which gives you a bit more control over the view. So the feedback zone is, as its name implies, when you do something, it gives feedback on what you've done. So there's a messages tab, and that's currently telling me I'm logged in, but without using Change Management Server, and it tells me about what I might have last done. There are also build tabs, which are used when you build or verify an application. There's an import tab for when you import a legacy application. There's reports, where you can get a list of anything if you've done a report. There's references. That's a really useful tab because that's an online cross-reference. So for example, if you select a variable in the variables tab in the Navigator, the references tab will tell you everywhere inside the application where that variable is used. And then you can double click within the references tab and you can open up that area of PAC Machine Edition inside the info viewer zone. There's also a comparison option. Whenever you do a verify, if you verify your current project on your computer with what you've actually got installed in your controller, the Compare tab will tell you if there are any changes and give you information about what those differences are. The final one on the right here is the Data Watch. The Data Watch is a way of viewing variable values. So you can see you've got two tabs there. You've got a static and an auto tab. The static tab, what you can do there is you can drag and drop variables from the variable list into the Data Watch, and then you can see the values of those variables when you're online to the controller. It's also possible to right click and add them in other ways. And you've also got an auto tab there. The idea of the auto tab is every time you select a variable on the screen, that automatically appears in the auto tab. So you can see the values on the screen, but also the Data Watch can give you information on those variables as well. Particularly useful for some editors, but increasingly we've enhanced all of the editors now, so that when you're online you do see all the information on the screen, so that auto tab isn't as useful as it used to be. You can also add new tabs. You can create your own Data Watch views as well. So for example, if you're tuning a PID loop or performing some sort of commissioning on a particular area, you could create your own Data Watch view for those items of interest, and then you can save that within the project. The final thing we have here is right at the bottom of the screen. This is the status bar. With the latest versions of PAC Machine Edition, this changes colour according to where you are and what you're doing. So we've got blue at the moment, we're offline. That would change colour when we're online. You can see in the status bar then on the right, you've got the current status, which again is offline. You've got how many faults there are and how many alarms there are in the system. It's telling me I'm running the local version of the project. And when you go online to a running PLC, what you would see there also is the status of your logic and your configuration, and is it equal to your controller and your PAC Machine Edition instance. And you would also see the current scan time of what you're running. So very comprehensive view, and at a quick view, it starts off looking very complicated, but the more and more you use PAC Machine Edition, the easier it is to see all the relevant information. And you can also, as I mentioned, you can move this around if you want something in a different place. If you don't want to see it all the time, you can close these. You can also use that pin, unpin button. And if you pin things in place, they stay where they are. But if you unpin them, then they slide out to the side. So they're still there, and you just need to move your mouse over the tab. But when they're not being used, they slide out of the way to give you more real estate. So we've got a lot of support here for different resolution screens, different size screens, different user and operating modes, and personal preference. So moving on from the base display, I've now opened the project, and you can see here in the Navigator we have the project tab selected. In order to make sure that you can see everything, what I've also done here is I've unpinned the companion, the feedback zone, the Data Watch window, and the inspector. They're still there. You can see the tabs along the bottom and the right hand side of the screen. And if I wanted to open those up, I would just move my mouse over those tabs, and then they would slide out from the bottom or from the side, and then I could pin them back in place if I wanted to. So in the project window, here you can see the details of my project. So in this case, I have a single target, and it's called CPL410. This is one of our edge controller targets. It's a IC695 CPL410 standalone controller. And what you can see here is you can see the tree of all the different aspects I have configured. So there's data monitors, that's used with our trending tool. Data watch lists, that's used with the Data Watch window. There are diagnostic logic blocks that you can run for diagnosis of faults. And that's either something that you might use under instruction from our technical support team, or you could create your own diagnostic logic blocks to diagnose faults during the evolution of the system. We've got the hardware configuration, and you can see the PAC Systems CPL410, and you can see there that some of these can be expanded. So by clicking the plus button, I could expand the configuration of the PAC Systems CPL410 to also be able to see the Ethernet configuration, the Profinet configuration, and then under Profinet, I'd also be able to see all the I/O devices configuration. I've got the logic node, and under that I can see program blocks and user-defined types. And again, if I expanded that, I'd be able to see all the program blocks, starting with the main program, and also any subroutines, user-defined function blocks, and anything else I've created. The next one is the reference view tables, and this is where we can display the default tables. So these are variables that are mapped to data tables such as %i, which is all of your input tables, %q is all of your outputs, %s is system status, %r for registers, and so on. And then we've got a variety of supplemental files. So not all of these are used. APM is for a legacy access positioning module. AUP is rarely used now, but that's for more Ethernet configuration files. Generally from our modern Ethernet interfaces, all the configuration is actually through PAC Machine Edition under the hardware configuration node. You've then got various documentation files and controller details. So the idea of the controller is if you put a file into there, you can double click that and open it up. And then if you put a file into that controller location, that will be downloaded as a supplemental file into the controller memory. So the idea there is that inside the CPU, when we download, it stores all of your comments, including things like variable names, variable descriptions, run comments, but also anything that's in that controller folder. Now controllers have limited memory, so you can also put documentation files in the documentation files area, and then that means that they will be stored with the project, but they won't be downloaded to the controller. So that's where you can put large files if you need them, such as AutoCAD or other files that can get quite big. And the final one there is initial value tables. The idea there is that when you create variables, you can give them initial values. And if you make changes to the controller and update those initial values, you can upload those initial value tables so that when you download, those initial values are part of the project. So that's very good for recovery after maybe the failure of a PLC, or if you're storing multiple projects across multiple PLCs, you can have those initial values as part of your application logic rather than have to enter all of those initial values manually. So here I've expanded the hardware configuration node, and you can see there the Ethernet and the Profinet configuration areas along with some Profinet I/O devices. And what I've also done here is I've double clicked on the PAC system CPL410 to open up the CPU configuration. So you can see the CPU configuration as a separate tab inside the info view area. And here you can see again you've got more tabs, and this is all the configuration for the CPU. The plan here is that instead of having to set any dip switches or do any separate configuration, all of the configuration is contained within the actual PAC Machine Edition project itself, and everything is authorized and controlled and allow you to set by either entering values or by clicking on pull down menus, or possibly by using radio buttons and so on. But generally the idea is everything is done using something that's human readable rather than have to do something with the physical hardware. So for the CPU, you can see we've got the main settings tab, which includes things like passwords and where the logic and configuration comes from. What does the run stop button do? Do you want to enable Modbus addressing? Do you want to enable DMP3? What are the modes of your Ethernet ports? And are you using network time sync? Where options are not available, they'll be grayed out. But where you've got something in black there, you can click on that and you can choose from the pull down menu, or in the case of these numeric values, you could enter a numeric value for that. For example, the watchdog timer, the default is 200 milliseconds, but for very large applications, you could enter a larger number in there or a smaller number if you wanted to have more tight watchdog control. On the next tab, we would set scan settings. Do you want to run to completion? What are your window sizes for communications? And you can also set things like a constant scan in there. Under the memory tab, you can select the memory sizes. A lot of the memory sizes are fixed, but for some of the memory sizes, like registers, you can increase the default size, and it uses more memory from your 64 megabytes in the case of a CPL410, but it allows you to have more storage for data. You can also configure things like %W. You can configure a particular set of memory that's used for fault checking, for fault bits. They're called fault locating references. And you can also configure the amount of memory that's reserved for symbolic variables. Under the faults tab, you can select fault categories. So fault categories would either be informational only, in which case it's logged into the fault tables, but the CPU carries on running, or you can have fatal faults that will stop the CPU from executing. So for example, if you had like a backplane fault or a memory parity fault, you can choose for that to be a fatal error that will stop the PLC. Scan sets, this allows you to distribute I/O scanning across multiple scan sets. Rarely used, but it could be used to optimize scanning. You could have fast scanning and slow scanning, for example. Then you've got the Modbus TCP address map. That's generally fixed, but that tab does at least show you what all the Modbus addressing is. For example, 0 addresses correspond to outputs, 10,000 addresses correspond to inputs, and so on. Now I've got enhanced security enabled, so I also have an access control tab, and the access control tab allows me to set what memory areas can be accessed externally. So this includes control of OPCUA variables, and it also includes access via legacy protocols to the data table. So for example, if I don't want anyone to read outside of, say, register 100 to register 110, I can set in the access control to only make that register 100 to 110 read and write, and I can have everything else disabled. Another option is I might have access control with read-only access to maybe register 200 to 210. So I can add that as an access control area for read-only. So there's a lot of aspects there for cybersecurity, and we do that by setting enhanced security. We enter a password for the project, and then we can also enter separate passwords as well, because we've got multiple password levels. So there's a lot of built-in security right there. The next tab is time. This is where you can configure the network time synchronization, and you can enable time offsets and things like daylight savings times. They're actually configured in the settings tab here, but the time tab gives you more control over what the UTC offset is and what the daylight savings times are. And the last tab is for your OPCUA server, so you can enable the OPCUA server, you can enable certificate protection, and you can also set various other aspects such as diagnostics and logging of OPCUA issues. So lots of configuration settings. If you're not sure, you can generally just leave the default, but the idea is this gives you a lot of control over the controller, over the PLC CPU, as well as the control of being able to have cybersecurity and other aspects. Now I'm in the same project, but this time I've expanded the program blocks area, and I'm looking at the main program. So within the main program, this is the program that always exists and is called when the CPU runs. And this could either be all of your application, or you might want to call subroutines or function blocks. So in this case, I've got a relatively straightforward logic example. And this is ladder logic, so you can see I've got my power rail on the left-hand side, as well as the other power rail on the right-hand side. And then I've got standard ladder type functions, as well as some function blocks. I've also got run comments, and I've also got calls to subroutines, and I've got that timer function block there, as well as the standard logic control. So here's a very simple logic example. I've got a start push button, so you can see the normally open contact with the variable start push button. If I had the data watch window open, you'd also be able to see the value of the start push button. But as it is, I can see the value there because the logic is showing me the status of power flow for that contact. So when you've got a contact which is green, that means that it's passing power from the left-hand side to the right-hand side. So I've got my start push button, that's on. My emergency stop is passing power. So normally you'd wire the emergency stop in the reverse state. So that's why it's a normally open, not a normally closed. And that means that I'm allowing my motor contact on the right hand side, that is energized. And then I'm also using then another motor contact on my main rung there to feed back and hold in that contact. So even if I removed my start push button, it would still hold itself in as long as the emergency stop push button isn't operated. On the next rung, I've got this timer function. So the motor 1 contact is an input to the timer. We've got a preset timer 5000, which is 5 seconds. And then on the output side on Q, I've got a contact for motor 2, and I can see the motor 2 delay time from the ET, the elapsed time contact there. So what that means is when I start my system, I hold down the start push button, motor 1 starts, and after a 5 second delay, motor 2 starts. And then if I operate the emergency stop, That removes power to motor 1, which also in turn removes power to the timer on contact, which would de-energize motor 2, so both my motors would stop. So very simple logic, and you can see there we've got the evolution of the logic with green to show you power flow, and also where you've got a variable with a value, that motor 2 delay, you can see the actual value and that updates in real time as well. Further down you can see we've got some more logic, and here we're calling some function blocks. So I've got an initialization block which is called, notice there's something that looks like a hash or gate FST_SCN. The Americans might use the pound sign, but I'm British and our pound sign is different. But the idea of that first scan, that's a system bit that comes on in the first scan. So you don't need to program that bit, it's automatically in the system for you, ready for you to use. And we've got other contacts like normally open for always on, normally closed for always off, and so on. We've also got like timer contacts, fault contacts. So there's a lot of contacts you can use there. So what you can see on that main program, when the reset button is pushed or when the first scan happens, we call an initialization block. And at the end of that, it turns off the reset. There's a reset coil to turn off the reset input. So that's like a one-shot. But we have also got one-shot contacts. And then we've got lots of other contacts and function blocks you can use to perform your operations. Notice at the bottom of the screen here, the status bar has changed colour. It's gone to orange because we're online. And you can see there it's got the currently active rung. The padlock shows that we're at password level 4, so that means we've got write access. The green globe symbol, that's telling me we're online. It then tells me the target I'm connected to, CPL 410 with its IP address. Tells me I'm in programmer mode. Programmer mode is the mode that we use when we make changes to the PLC. You can also go online in monitor mode where you can't make changes, but you can view the logic and see what's going on. You can then see I've got run enabled, so the PLC is running with the outputs enabled. The configuration is equal, which means the configuration in the PLC is the same as in my laptop, and the logic is equal. So the logic in my laptop and my PLC are the same as well. And you can see my current sweep time is 0.6 milliseconds, so it's a very fast CPU, this one. And my OPCUA server is running, and I've got 2 faults, and I've also got no warnings. So that's what that status bar is telling me. If I wanted to see the faults, I would double click on the target, which you can now see has a green icon next to it, a green sort of square. That green means we're connected. If I was to double click on that icon there, then that would open up the fault table in the info viewer to enable me to see what's going on with my PLC. Here's a structured text block. In this case, I've implemented a quadratic formula. And the idea of using structured text is a Pascal or Delphi based application language which allows me to program in a different format to ladder logic. Ladder logic represents relay ladder, whereas structured text here is more of a high level programming language. Structured text is very useful for things like sequences. It's also useful for algorithms where you want to program some sort of mathematical application. And you could do that in ladder, of course. Ladder logic does support sequences, it does support calculations, but it's much easier to see everything using a text-based format like we have here. So you can see we've got standard functions like if, then, else. We've also got function blocks like square root. We can get access to the variables. And in this case, you can see because we're running and we're configuration equal, you can also see tooltips for the values. So it tells you what the current values of all of those variables are. So a very good way of finding out what the evolution of the application is, because that appears inside the structured text editor. And we have updated this editor recently, so it's also got color coding. So the different colors indicate different things. So green is a comment. You've got blue for instructions and functions. You've got black for things like built-in PLC functions like square root. And then it's a sort of reddy brown color indicates a variable. And then you've also got a slightly different greener color, which is used for parameters, because this is a parameterized subroutine block. And here's function block diagram. So slightly different editor again. Now we have function blocks. So there's less of a program flow with this, rather than executing from rungs from top to bottom and left to right, which ladder logic does, or from top to bottom, which is what the structured text does. Now you have these function blocks, and the number within each function block tells you what the execution order is. So with function block diagram, this is ideal for process type applications, and it is possible to mix and match all these different application types in the same application. So you could have ladder, you could have structured text where you need routines and algorithms, you could have function block where you're doing process control, and you can mix and match all of those within the same application. It's also possible to integrate C programs as well, but I'll have a separate slide deck on that one. Now with the function block diagram, again I'm online, so I can see the values of the parameters which I'm connected to. So for example, LC101EN is the enable input, and you can see that's on. And then I've got a level indicator, LI101AI, and you can see the raw AI value there is 0. And then you can see I've got a variety of blocks. So I've got an analog input block, which has got an associated set of parameters called LI101. So that's my level indicator. I've got a fan out. This is used to have a single input with multiple outputs. This one doesn't have any instance, so it's just a simple function block. But then I've got my PID controller, LIC101. And then I've got an alarm block as well, AL101, and you can't see it, but on the right hand side I've got my output to the actual analog output integer block, which is my actual analog output valve. So I've got a PID routine here with alarms. Now I've currently selected the LIC101 block, so what you can see there is this is a process oriented block, and as well as all of the parameters, by opening up the inspector we can see more detailed parameters for the PID function. So you can see its description, level controller 101, you can see how it's operating, you can see here how it's initialized, and if you look down about 2/3 of the way down, you can see the actual PID values. So I've got a proportional gain of 1, an integral of 0.2 and a derivative of 0.1. I've also got some filtering, I've disabled set point tracking, I've got my process variable minimum and maximum. So what you can do inside this tab is you can select all of the aspects of your PID block and how it will function. So this is very good for process oriented applications, and as I mentioned, you can mix and match. Now I haven't mentioned how you create these programs yet. The way we create programs is by opening up an empty block or by opening up an existing block, and what you can do is you can select and add functions in a variety of different ways. So when you're programming ladder logic, you can either use the Toolchest, which would be a separate window which I'm not displaying here, and you can drag blocks in from the Toolchest. It's also possible to enter mnemonics. So if you know what a mnemonic is for normally open contract, NOCON, you can just type NOCON at a open location and it will insert that contact for you. And then once you've got the contact or the function block, then you can assign the variables against it. But you can also go to the variables tab and you can drag and drop from the variable tab onto a contact or onto a function. So nice and easy to edit, and you've got options there for things like deleting, opening up spaces, copying and paste. You can also import and export as well. So you can copy and export to say Excel, and you can edit in Excel or a text editor. And you can also import and export using other formats. For structured text, it's just typing. So you just position the cursor and type the names of the functions you want. Again, there is support for copy and paste and drag and drop. And for function block diagram, again, it's very similar. You either use the Toolchest or you right click on the screen and you would insert instruction, and then you would insert the instruction using its mnemonic or by selecting from a list, a pull down list of all the available instructions. Once the item is on the screen, you can then join the function blocks together. And the way you do that is by clicking on a pin and then dragging to the next available pin on the other function block. And then what you can also do is you can assign variables as well. So again, by dragging and dropping or by typing the name in of the variable. And then the final aspect would be to select the instance of the variable, for example, as I have here, LIC101, and then in the inspector, you would enter the properties for whatever that function block needs. Once you finish that, you then get the option to verify your application, and at the verify stage, that would show you if there are any errors which would stop it being downloaded. And then when you go to download, there are some additional checks as well, just in case there are some errors which will stop again the application from being downloaded. And they would appear in the feedback zone. All being well, everything would be downloaded, and then you get the option to run the PLC and check the operation of your logic that you've created. Now, if you don't have the physical device present, we have added the simulator in 10.6. And the way this works is when you connect to your device, what you do is you go to the target menu and there's a connect button, and you can either connect to the physical device, and the way you would do that is by going to the target option and you would enter its IP address, or there's an option to connect to the simulator which uses a local IP address. Now, the benefit of using the simulator is, of course, you don't need your hardware, but also it allows you to try things out before you actually connect to the physical device. So it's a great way of making sure that any logic changes you're going to do will work. The potential is, whenever you do any online change, you might change the logic in a way that is valid in terms of being able to be downloaded, but maybe stops the machine from operating. So the simulator is a great way of testing things out before you actually get to the physical machine. So we're online to the simulator. Notice that the status bar at the bottom is grey. The simulator is completely isolated from the real network, so there's no chance that the simulator will be able to interfere with your plant. And the other thing with the simulator, it doesn't have any I/O. You can simulate the I/O by using data tables and variables and entering values, but the actual I/O is disconnected. So it's intended to simulate the logic, but it's not a full simulator. You could make it a full simulator if you wanted to. There is a sim variable, so you could write simulation code to simulate your machine, and I have done that successfully with various applications. I've simulated the logic so that you take the outputs and then in your simulator logic you feed those back to inputs. The challenge is, do you know your machine well enough to be able to simulate every instance of operation? And also, how complex is that logic? In some cases, the simulation might be as or more complicated than the actual machine itself. Also, what I found was, because the machine would have real-time delays, I had to use a lot of timers in my simulator, because otherwise everything would have been so fast I wouldn't have been able to view it. So, for example, when the output turned on, I then had to wait a few seconds by implementing a timer before that device was actually started, and that was to simulate, for example, running a conveyor or opening a valve or whatever. So so the simulation is certainly possible, but it can be a bit complicated. But again, it's a great way of testing things before you get to your machine. Okay, once you've connected to the simulator, it behaves in exactly the same way as a PLC. We've done a lot of work to make it identical to a PLC operation. So things like upload and download operations are the same. Things like forcing, things like being able to monitor and control, all identical to a physical device, except for it's running in your computer. There's a couple of things which are different. First of all, of course, because it's inside your computer, you don't have any status indication. So we give you this separate simulator window you can see on the right. So that tells you the state of the PLC simulator. Is it on? Is it running? Are there any faults and so on? And the other thing that is a bit difficult to do is to simulate the speed of the controller. So you may find that what runs on your computer is running at a different performance level to what's running inside the actual PLC. And the reason is that we can't easily control how fast the computer runs. So you might find things run slightly slower in a PLC, or if you've got a slow laptop, maybe they'll actually run faster inside your simulator because you might have a very powerful laptop. So there might be some timing differences there. Again, when you come to simulation, that's where you might want to put in delays and things to make sure that things operate in a way that you can see them, and so that you've got some control over what's going on. But the simulator, great feature. It's included as standard in the PAC Machine Edition Professional version, and again it allows you to operate the PLC in the same way as if it was a physical PLC, but without actually having to have the hardware present. Great for simulation, also good for emulation, also good for things like sales, demonstrations and so on, and a great way of being able to show off PAC Machine Edition without having any hardware. Now, so far we've demonstrated the logic, and you can see the logic evolves online, but on this slide here we see the Navigator. So in the Navigator, I'm not displaying the project window anymore. I've now moved along to the variables tab. So you can see the variables tab is selected, and this has a list of all of your variables across all of your targets. In this case, I've only got one target, so everything appears quite straightforward. But if you had multiple targets, you'd see the names of the target prefixing the name of the variable. And then if you want to, you can sort that variable list. So the default sorting is by name, and it also filters out system variables, but you can filter by target, you can filter to add system variables, you can filter by certain names. And if you've got lots and lots of variables, it also filters automatically, so you get so many variables per page, and then you navigate across multiple pages. But you have got filtering capabilities there. You've also got import and export capabilities, so you can select one or more variables and import or export them. You can also copy and paste, and you can both copy and paste within the Navigator or to an external application. So there's lots of ways you can manipulate your variables. Now I've selected the analog input 01 variable. Notice that I'm configuration equal and logic equal down along the bottom. Again, I'm orange now, so I'm actually online to a real PLC. And this time I've got the inspector open. So what you can see is you can see the name of my variable on the left-hand side in the Navigator. And on the right-hand side, we've got the detail of that variable. So it's called analog input 1. I haven't given it a description, a bit naughty, but on the other hand, analog input 01 is quite descriptive. You can see it's published, so it's external read-only, and there's an OPCUA access level as well there. You can see whether it's got an array. In this case, it's not an array, it's a single point. The data source is from the controller, and you can see its physical reference address. In this case, it's not a symbolic variable. I've actually mapped it to analog input number 1. Now we use that percent. The percent tells you that if you see percent inside a variable, that tells you it's a physical address mapped to a data table. So that's what that percent means. So I is inputs, Q is outputs, AI is analog inputs, AQ is analog outputs, R is registers, S is system, M is memory coils, and you might have a few other types as well. So we've got %W for bulk memory, and we've got some legacy %G addresses, which stands for Genius data. They're still there for legacy applications, but you normally wouldn't use those. You then see the data type, you see the current value, which is 0, and you see the initial value, because it could be that the initial value, particularly if you were having some sort of like set point arrangement, the initial value might be different. And then you can also choose a default display format. So in this case, it's decimal, but you might want to choose hexadecimal or maybe octal or some other numbering type process. And you can also see there, is it retentive? Retentive means that value of that variable is stored across a power fail. And the default for most register type values, including analogs and inputs and outputs, is retentive is true, but for discrete values, the retentive is false. So what would happen is if you've got, say, a Q output, that would normally be reset across a power fail, but you can make it retentive if you want to by setting that property here inside the inspector. So a great way of seeing what the values are and what the details of the variable are. And again, you can also relate that with the data watch window. So the data watch auto area would give you the value as well. And you can also go into the feedback zone, and in the feedback zone there's a reference tab, and what would happen is if I select analog input 01 and then go to the reference tab in the feedback zone, it will tell me everywhere throughout the logic where that input 01 is used. And then I could double click on the reference area in the feedback zone, and it would open up that subroutine or that reference location where the analog input 01 value is used. So very good for fault finding, because you can use that to maybe start at the end, the output, and work back to see what interlock is maybe stopping the output from operating. Or you can do it the other way. You could start on an input and then move forward to, again, find out what interlock or what other function is not working and why your process isn't running as you expect it to. And here's the data watch window. So again, I've got the Navigator open, I've selected a variable, and then you could see that variable in the data watch using the auto tab, or in this case, I've actually created a data watch by dragging and dropping from the Navigator. I've dragged and dropped the variable names I want to see into the data watch, into the static view. So in this case, I can see the analog input itself. I can also see the overall alarm value, and I've got a high alarm and a low alarm. So you can see there's the address for the analog input 01, because that one is a mapped variable. For the alarm, high alarm and low alarm, they are symbolic addresses or symbolic variables, so there's no address. And then in the value column, you can see the number of the analog input, and you can see the on or off state for the actual alarms and high alarms and low alarm values. That value, that would appear according to the setting inside the expector, which is your display format. So you can have other display formats as well. So maybe you don't want to see on or off, you want to see open or closed or true or false. Maybe you want to see different values like hex or octal or so on. So you can set that inside the inspector. Now the other thing you can do is you can go into the project tab and you can scroll up to data watch, and you can right click on the data watch node and you can create a new data watch, and then you can double click on that data watch and it will appear in the data watch list here. And then again you can drag and drop variables into that new data watch in the same way as you use the static data watch. So that's brilliant and ideal for things like your PID loop tuning, where you want to see a few PID values. Maybe if you want to configure a particular portion of the machine and you've got a combination of discrete and analog values, so it lets you see and control all of those. And in terms of controlling them, if you want to change a value, you go over to the right hand side here, click in the value tab in the value area, and you can enter the new value, and then it will write that new value to the PLC. Now the only restriction there is the value can only be written if you've actually got write access. It might be that the PLC itself is overwriting some of these values, so you can't write everything. So you've also had the option to right click and force discrete values. So the way that works is it overrides the actual value in the PLC with the value that you forced it to. So the PLC value will no longer take effect. It will actually have whatever your force value is. Now that's dangerous because you could turn on an output, and if the force remains, the output will remain on even if any interlocks try to stop or turn off the output. But it's a good way of testing applications, but you just need to be a bit careful on that one. You can't force analogs, at least not directly from the data watch window, but what you can do is using the analog input function blocks. They do support forcing, so there is a way of forcing analog inputs, but you have to do it through a function block. Or you could also implement your own override logic as well using function blocks in the logic, and you could have like an analog input actual and an analog input force, along with a bit maybe which toggles between the two. So there are ways of forcing analogs, but it requires a bit more work and a different approach. But Booleans can be forced. Now if you've got mapped variables, then you can expand the reference view tables and you can look at all the default tables. It's also possible to create a custom reference view table, but I haven't done that for a while. I normally just use the default tables or a watch window these days. But here you have the default tables. So you can see AI would be a list of all the analog inputs, AQ is analog outputs. You've got Genius, inputs, internal coils, output. And here we're showing all of the register table. So it starts with register 1, and you can choose the direction, whether it's left to right or right to left. I think the default is the wrong way to how you would expect it. So you can go into the configuration settings and you can change the left or right to left view. You can also change individually for each of these cells what the display format is. But here we're displaying in decimal, so you can see the value for register 1 there. This is the one at the top right, and you can see it's got a value of 50. And then we're moving along to the left. We've got register 1 to 10 on the first line, 11 to 20 on the second line, and so on. And these would evolve in real time. And just like with the data watch, you can click in one of these fields and you can change the value. You can also right click and force if it's a Boolean value. So very similar to the data watch, but now you're looking at a complete table at a time. And as I recall, you can always create a custom table as well, mixing various values together. We also have a data monitor. The idea of a data monitor, and this was updated in version 10.6 and again in 10.7, the idea of a data monitor is that you can actually have a trending tool inside PAC Machine Edition that can trend the values of analog and discrete variables. Probably not so much use for discrete because they're either on or off, but really useful for analog values. So for example, if you want to trend a value, if you're tuning a PID loop, or if you're controlling some sort of analog device, what you can do there is you can go into your data monitor inside the project tab. You can create a new data monitor window. You can then drag and drop variables from the variable list onto that data monitor. And then when that data monitor is running, it records all of those variables onto a trend window. What you can also do with that data monitor is you can save those variables and save those trends. You can either export them as a useful file format and analyze them externally, or you can also import and reuse those data monitor files from previously to compare them against current operations. So a very good data monitor tool to allow you to monitor analog variables as well as just having the instantaneous value. Now the tool chest has multiple uses. It contains all of the instructions, including the mnemonics for things like ladder logic, which is what we're showing here. It can also be used to store code snippets, it can be used to store subroutines, and it can be used to store other items which are used across multiple projects or multiple targets. It's also the location where all the GSDML files are stored, and it can also be used for GSD and other files for legacy type field buses. So the way you display the tool chest is you go to the view menu and you click the tool chest option, and then the tool chest appears, and then you can see you've got a set of drawers, and what you can do is within each drawer you can select those drawers using the pull down menu, and you can see the contents of all of those drawers. It's also possible to create your own drawers. There's also a drawer for the active project, and what you can do as mentioned is you can drag and drop things from your application into those drawers, and that could be code snippets, completed function blocks, sets of variables, and then you can bring those back out of the tool chest into a new application later. So it's a great library of things that you might use commonly. You can also export and import tool chest drawers as well. So for some examples of some modules, for example the RSTI EP5261 serial module, we have Modbus RTU function blocks, and we can distribute a drawer, and that allows you to implement those function blocks very easily just by importing into the tool chest and then dragging from the tool chest into your project view, and then they get added into the application. So great way of using common applications and also getting access to all of your files and other things that you might need, and also sharing common function blocks and other features with other users. Now, if you can't find something, we've got lots of built-in help for PAC Machine Edition. First of all, you've got the companion, and from the companion you can click on the question mark blue button, and that will open up the info viewer environment. You can also go to the Navigator. If you scroll along with the tabs on the Navigator, you'll see info view is the one on the right, and within that one you've got lots of categories that you can select from to find help entries. And you can also go to the top right of PAC Machine Edition and you can click on the question mark magnifier button, and that brings up Machine Edition Help Search, and from there you can type in the search bar and you can find the topics that might match what you're looking at. So lots of comprehensive help in order to enable you to find things and be able to use the application. And that also includes details of how the programming instruction set works. So we do have a programming document book that explains all of the functions, but they're also all within inside PAC Machine Edition. So for example, if you want to know how a timer works, you could either enter the timer or you could search for the timer function. And then what you could do is you could look at what all the input parameters are, the output parameters, the member variables that are defined, and it tells you how the timer works and gives you all the information you need without having to actually go out and read a separate manual. So a really good way of finding information. And then in the help menu toolbar, there's also more ways of finding information. So you've got search, you can display the index from there, you can go to product information, you can contact support, you can also look at our educational services for training courses, and that's also got license information there as well as a link to our Emerson website. So lots of ways of getting help about what it is you might need to do with PAC Machine Edition. So to summarize, PAC Machine Edition gives you an advanced programming and configuration environment with multiple aspects. It gives you access to all your projects and applications. It gives you software-based configuration with virtually no need to configure dip switches. There are one or two cases where you might need to configure dip switches or add jumpers, and that's, for example, on the PAC Systems RX3i chassis-based controller. The expansion racks have a rack number configured with dip switches. And on some of the analog modules, you use a jumper to set 0 to 20 or 4 to 20 milliamp mode. But that's about it. For everything else, everything is software-based configuration. Even for Profinet, with that Profinet configuration support, that includes the capability to configure via the GSDML file, and that includes the configuration for all of the I/O modules within a configurable Profinet I/O device. So for example, with an analog module, you can go in and set the individual channel setups, is it voltage or current? And then for each channel, you can set the actual range. For example, again, is it 0 to 20 or 4 to 20? So all of that is configured through PAC Machine Edition. We've also got the full object-oriented IEC 61131 Part 3 programming. And you've got lots of capabilities for application documentation. So again, nicknames, you've got run comments, you've got comments for the application itself, you've got comments for variables, and that even includes additional files, and those can be uploaded and downloaded to and from the PAC Systems controller. So the great benefit there is, that when you go to a controller, even if you don't have a backup on your disk, you can upload from the controller, and then you've got the latest version. There's lots of commissioning and testing tools, such as the Data Watch and the Data View tables and the Data Monitor. And we've also got great simulation, so you can simulate without the hardware, and you've got really good online help. So if you get stuck, there's lots of information to help you get going. So the upshot is, PAC Machine Edition gives you all the comprehensive tools you need for programming the PLCs, but it's also very straightforward to use with a very short learning curve. And anyone who's done any sort of PLC programming with any other PLC, they should find it very quick to adapt to PAC Machine Edition and very quick to start programming and also testing and developing applications and commissioning and fault finding on existing installed applications.